Hey everyone, this video is going to be discussing conic sections following up from a previous discussion. Specifically this one we're going to be looking at circles and ellipses. So first of all, the circles. Circles you may recall back from high school math class, you probably talked about it a little bit. Specifically, what is a circle? Well, a circle is simply all points in a plane that are at a fixed distance from a point. Now that sounds a little bit wordy, but if you really think about it, it makes sense. It is all points that are at a fixed distance from a point. In other words, it's all the points that are the same distance from another point. And if you look at the circle that I have drawn over here to the side, the circle itself it's not the center, it's not the whole thing, but it's just the line going around if this was a perfect circle. And all those points on that circle are always the same distance away from the center. And that distance that it's away, we refer to as the radius. And as you know, the radius of a circle, it's always the same no matter where you draw it from the center to the circle itself. So that's what it means by all points being at a fixed distance from a point. Okay, if we get on down to the equation of a circle. So the equation of a circle follows this format. X minus h squared plus y minus k squared equals r squared. And in that setup, it gives us the key information we need in order to be able to draw a circle the right size and also in the right location. So the location part comes from the center. So notice in this situation, based on the formula, what we're saying is this h and k component inside these parentheses give us our center location. And then as far as size, that's going to be this number down here at the end. Now the number at the end over here by itself in the standard equation of a circle setup is r squared, meaning that it is our radius is r squared. Now let's look at that with a specific example so you can kind of see how this plays out. So in this equation that we have in here in this first example, I have the equation x minus 5 squared plus y plus 3 squared equals 16. So you can see how this equation follows that format of our standard equation of a circle. It has the exact same matchup. So now if we break it down and understand that our center is going to be located at HK, which are the constants that are coming from the numbers inside of the parentheses with our x and y, then we can locate the center. So in this specific example, I would have that the center, and I'm just going to abbreviate that with C, is located at the coordinate. So let's look at what numbers we have inside. So inside I have x minus 5. Now notice up here in my standard equation of a circle, when it's x minus h, the center, the x component, will be at this h spot. So x minus h, whatever h will be, is that x component of the center. So here I have x minus 5. So x minus what? And it is 5. So there's that first component for the center of the circle. Now similarly, when we look at the y minus k, that's my format. That's the standard form, what I'm looking for. And when it's in that y minus k format, the y component will be k. So I have to think about this. Notice here what I have, y plus, not minus. So I have to think about this in terms of a y minus situation. Y minus what is giving me this y plus 3? Because if I can figure out what goes inside this square, then that will follow the format of my equation, y minus k. And in this case, to get a plus 3, it would not be a plus 3 here, because if I do that, I would simply have y minus 3. So this would have to be a minus 3 or a negative 3. So if I have y minus a negative 3, that will have the result of this plus that we have in our example. So the y component would be a negative 3. Another way of looking at this is basically whatever is inside of your equation, it will come out as the opposite. So a negative h comes out as positive h. Negative k comes out as positive k. Similarly, negative 5 comes out as positive 5, and positive 3 comes out as the opposite, negative 3, to give us our x and y component for our center. Okay, so now that we've done that, let's look at the radius. So notice here at the end of my standard form that the number over here represents the radius squared. So this 16 that I have here is not the radius. This represents the radius squared. So to figure out what my radius is going to be, I need to think about, hey, if this is the radius squared, then what would r have to be so that when you square it, it gives you this number at the end, 16. Well, this one we can see immediately. Some others may not be as quickly obvious, so we think about how do you solve an equation, and the opposite of squaring would be to square root. So if I was to square root this side, square root this one as well, those are inverse operations, so I would be left with r is equal to the square root of 16, which would be 4. Actually, it's plus or minus 4, but r here is a distance measurement, how far it is from the center to the edge, and distance cannot be negative. It would not make sense. So in this situation, our radius would be 4. So to figure out our center and our radius, we have done that based on this equation. Now, every equation is not going to be set up in this nice format to where you can just instantly see the center and the radius. Sometimes things get a little bit messy, and we have to figure out how to work around that. So let's check that out. Okay, so here in this example, we have x squared plus y squared minus 16x plus 14y plus 32 equal to 0. Now, just looking at this, obviously it is not in that standard form, which I have rewritten here in blue up at the top. You can see it does not match. It's not exactly the same. You can probably see some similarities. For example, you do have an x squared, you have a y squared, and you have some other stuff, but it's not in that correct format. So in this situation, for us to figure out, well, hey, what is my center, what is my radius, for us to get these answers, we need to write this in this standard form. So we're going to have to play around with this, move some things around, shift some numbers around, and get it in this format. Okay, so let's kind of break this down and look at what happens. First of all, I need the regular number to be over here on the other side all by itself. So that's the first thing that's obvious. So I'm going to take this 32 and let's move it over to the other side. And if I do that through subtraction, then it would move over here as a negative 32 because we would have to do the opposite of addition. All right, so after that, I am going to group the x's or the x pieces together, and I'm going to group the y pieces together like that. And again, the 32 we moved over to the other side. Okay, so now what I recognize is this is a perfect square. X minus h squared, that's considered a perfect square. So what we need to do is we need to figure out what would this be if it was written out in expanded form, which we kind of have the pieces of that, we just don't have the whole set. So in other words, if I think about this, get that out of the way for a second. If I think about this like this, then I need to figure out what would be the third part of this trinomial that would result in this x minus h squared. In other words, that would result in this perfect square. Now, we've been doing this a little bit in previous lessons, so hopefully this is not totally strange to you. And to have that perfect square set up with our trinomial, what you have to do is figure out the right pattern. And that pattern is going to come from a number here such that whatever we put, let's kind of take a step down for a second, actually. So if I think about it like this, where this is my end result where I want to be, whatever number I put in these spots, let's talk about this for a second. Whatever number I put in this spot, if I square it, it has to give me this number here at the end, in this step where we're actually at. At the same time, whatever number I have here, if I combine it with the x and then double that, it has to give me the number in the middle. So you have to kind of think in reverse of that. And if you need to go back and play that again to kind of break it down a little bit slower, please do. So again, let me say that again. These two numbers, whatever I have here, they have to multiply together and then double to give me this number in the middle. So let's flip that around backwards. Instead of doubling them, let's go from here to here and do the opposite of doubling. So the opposite of doubling would be to half it. So if I take half of negative 16, then that would give me a negative 8. So if I put that as minus 8, again, let's kind of work it backwards now. If I combine these together, that would be a negative 8x, and then double that, it gives me my middle term. Now, as far as figuring out what goes here, to keep this pattern working correctly, remember I said that if you take this number at the end and you square it, it has to give you the number that's here. So in that case, what would have to be here if I square negative 8 would have to be a positive 64. And now this is considered a perfect square trinomial because it can be rewritten in this format. So notice that the 64, that was not originally there, and I want to change the color of that. And you'll see why here in just a second. So let's put that as a plus 64. There we go. And now that can be rewritten like this, which is what we want. And you'll now notice how this looks like my standard form. Same thing with the y. Half of 14 would be plus 7. So I can go ahead and put that in here. And then to finish this out so that it would have come from the way it's supposed to, that would have had to been a positive 49. By the way, whenever you're trying to figure this out without having to do so much back and forth, the quick step is to take half of this number, which would be plus 7, and then square it. That's what should be here at the end. And you can see now we've created two perfect square trinomials that can be rewritten like this. This is called completing the square process. Now, the two green numbers that we just wrote in here, those were not originally part of the problem. So we've kind of changed this problem from its original format. It's no longer balanced in the structure of what it was originally. To restore that balance, I have to apply those same new pieces over here to the other side of the equal sign. So I put in a positive 64 and a positive 49. So let me write these over here like that. Whoop, there. Well, if I can get it there right. Okay, it doesn't want to, so let me kind of back up. I think I'm too close to a certain part there, and I'm going to put plus 49 there. Okay, so now let's clean this up. If I put all these pieces together, negative 32 plus 64 plus 49, I think that comes out to be 81. Now, if you'll notice, we have now rewritten this circle equation to look like my standard form. And with that being the case, we can now identify this center and radius of what we're trying to find here. So let's see if I can move this down here, and let's figure this out. Okay, so my center, remember, it comes from these components here, and it's the opposite. So the opposite of minus 8 or negative 8 would be a positive 8. Opposite of 7 would be negative 7. There's my center. And my radius, remember this is the radius squared. So if that's the radius squared, then r would have to be 9. And that's how you write the equation of a circle, and that's how you figure out the center and the radius. And of course, now if we wanted to graph this, we absolutely could. So I would simply go and look at a graph, go to right 8, down 7, 1, 2, 3, 4, 5, 6, 7, 8, go down 7, 1, 2, 3, 4, 5, 6, 7. That would be my center. And then I could go out 9 in all directions. So that would be up 7, 8, 9, which is going to be somewhere here. I'm just going to sketch this a rough estimate so you can get the idea. I'm running out of room. So let's see if I can make this a little bit bigger. There we go. So this is not going to be a pretty circle because it's a sketch, but you would get the idea. And that's how we could graph it based on that information. Okay, so that's circles. Hopefully that wasn't too bad. Hopefully that was a review. Ellipses probably are going to be a little bit new, so let's go over and look at a few examples of how that would work also.